Hi, I am Bambi Jae Caparoso, and I am going to teach you now all about parabola. According to the definition, parabola is a set of all points in a plane equidistant from a fixed point and a fixed line in a plane. The fixed point is called the focus of the parabola. The fixed line is called the directrix. Always remember that the length of the focus from the vertex is equal to the length of the directrix from the vertex. The line through the focus and perpendicular to the directrix is called the axis of the parabola. Therefore, if your focus is in the x-axis, your directrix also should be in the x-axis. The chord drawn through the focus and perpendicular to the axis of the parabola is called the latus rectum of parabola. Find the equation of parabola having its vertex at the origin, axis along the x-axis, and passes through the point 4, 2 and sketch the graph. Okay, now we are going to use the formula y squared is equals to 4ax. And then we're going to substitute using the given points. And then we're going to multiply. In order to get the value of a, divide the number of coefficients. And then we're going to cancel and then divide 4 to 16. So the answer is, so the value of a is 1/4. As we all know that the vertex at the origin. So our vertex is at the center. Or our vertex is at 0, 0. Or at the origin according to the given problem. Next, we are going to get the focus using the formula F. So our formula of the focus is A, 0. We can get the focus through the value of A. So, according to the value of A, 1/4. So our focus is 1/4, 0. Then next we are going to get the value of the directrix. The formula of the directrix is x is equals to negative a. Therefore, our directrix is x is negative 1/4. Since the value of a is positive 1/4, will be multiplied to the negative of a. The answer is x is equals to negative 1/4. Okay, we're almost done. Next to that is to get the latus rectum using the formula LR is equals to 4a. Then we are going to substitute it using the value of a. So 4 using the value of a is 1/4 is equals to 4/4 and then divide is equals to 1. So according to the definition, we need the two length of latus rectum, so we need the two branch of it. We're going to branch the value of latus rectum. So 1/2 and 1/2 right here, and then the value of 1/2 is equivalent to 0.5, and so this is 0.5 and this one is 0.5. Okay, we have already here the endpoint of, okay, we are going to determine first the endpoint of the latus rectum. So the endpoint of LR. Okay, so we have here the two endpoints of the latus rectum. So we can already graph the parabola using this given answers. Okay, we're going to use first the vertex. According to the problem, the given problem, our vertex is at the origin. Vertex at the origin. So, since the vertex is at the origin, we'll locate the point here. Then next to that is we're going to locate the focus. Okay, our focus here is at 1.4, 0. So somewhere here. Okay, and then our directrix. So our center is 0, 0. I mean our vertex is 0, 0. And then our focus is 1.4, 0. And then we're going to look at next the directrix. Okay, the directrix is the same as the equivalent of the focus to the vertex, and then the directrix is the same as the length of the focus to the vertex. Yes, our directrix is -1/4. So -1/4, 0. And then the next is to locate the endpoint of the latus rectum. Okay, the endpoint of the latus rectum is 1/4, and 1/2. So somewhere here. And then our one endpoint is 1/4, -1/2. So it is somewhere here. And then we can already draw or sketch the graph of the parabola. Okay, and then this point going down here is called our latus rectum. And then this, by the way, this is a latus rectum. And then this line here is our directrix. So I think that would be the explanation of the given problem being stated right there. Okay, we are done with the first problem, which is the vertex is in the origin. So I have here this second problem, which is quite different from the first one. So given the parabola having the equation x² minus 4y plus 6x equals 3. Find the vertex, focus, and length of the latus rectum and sketch the graph. Okay, first we are going to copy the given equation, which is x² minus 4y plus 6x equals 3. And then we are going to group all the x and transfer -4y to the other side of the equation. Okay, then we're going to multiply 6 by 1/2 and we are going to square it. So the answer is 3² equals to 9. Then we're going to extract and completing the square. So x² plus 6x plus 9 equals 4y plus 3. Then we're going to get the factors of the given equation. Okay, then we're going to add the positive 3 and 9. So cos 4y plus 12. Okay, 3 plus 9 is equals to positive 12. Then we're going to factor this out. So Okay, in factoring. So we come up with the standard form of this equation, which is this one, the standard form of the equation. Then, since the parabola opens upwards, our vertex is in negative 3 and negative 3. Okay, negative 3 and negative 3 is come from these two numbers, the positive 3 and the positive 3, and then in the vertex it comes negative 3 and negative 3. Then we're going to solve for the value of a using the formula for a equals to 4. For a is equals to 4. And then we're going to divide by 4. Then cancel. So the value of a is equals to, the value for a is equals to 1. Then the fact that the points of the focus determine the value of a. So the point of our focus is negative 3. Our focus here is negative 3 and negative 2. Okay, negative 2, since our value of a is 1, will be subtracted to negative 3, or negative 3 will be subtracted by positive 1. So the answer is, our focus here is negative 3 and negative 2. Then let's find our latus rectum. We're going to find our latus rectum using the formula. Okay, I'm going to put it here. Latus rectum. Okay, we're going to find the value of our latus rectum using the formula for latus LR equals to 4A. So since the value of A is 1, we're going to substitute. Okay, and then the answer is 4. So according to the definition, that we need to get the 2 branch of the answer of the latus rectum, which is the 4. So we need to get the 2 branch of it, the positive 2 and negative 2, total of 4. And then so our endpoints of the latus rectum are negative 1. Our endpoints of our latus rectum is negative 1, negative 1 and negative 2. And then the other endpoint of the latus rectum is negative 5 and negative 2. Okay, negative 2 here is came from this number negative 2 from our focus. And then negative 1 is subtracted by this number negative 3 and by 2. So since this is negative 1, and then negative 5 is negative 3 added by negative 2 will be negative 5. So I think this will be the things that is being provided in order for us to graph the parabola. Okay, first we are going to locate our vertex, negative 3 and negative 3. Okay, negative 3 from the x-axis and negative 3 from the y-axis. Okay, it is somewhere here. Negative 3 and negative 3 from the y-axis. And then next one is we're going to locate for our focus. Okay, our focus here is negative 3 and negative 2. Okay, negative 3 from the x-axis and then negative 2 and the y-axis. Okay, somewhere here. And then we are going to locate our latus rectum using the given the given endpoints of the latus rectum, negative 1 and negative 2. Okay, somewhere here. And then negative 5 from the x-axis and negative 2 from the y-axis. Okay, somewhere here. And then we are going to graph now. Okay, since this is a to make it clearer, let me label the following points. This is the vertex. Okay, our vertex here is negative 3 and negative 3. And then our focus is negative 3 and negative
Sige.
Okay, and then we're going to graph our parabola using this being provided things. So our parabola opens upward. Okay. Okay, and then our value of A indicates or being used to locate our directrix. Okay, our directrix here is since 1, so we're going to subtract 1 to make it. Okay, we have already here the directrix and then the latus rectum. Okay, so this would be the sketch of the graph of the given equation. So we already find or sketch the vertex, the focus, and the length of the latus rectum. So this is the vertex, this is the focus, and the two endpoints of the latus rectum, and then the directrix of the graph. So that should be all. Thank you.